Hello everyone, so this is going to be the sixth video of our HLD series, and in this video we are going to study about the event ticket booking system. This is the part 2 of our ticket booking system section, so I will recommend you to watch the part 1 of about the movies so that you can understand the basic concepts and everything. And let's get started and study our system design. So, in the ticket booking system part 2, I just made a beautiful drawing of a Taylor Swift concert. So, let's first of all make you understand a little bit why we need this event booking system a separate video. So, there is a small difference that I wanted to mention. While we are making a movie ticket system, we have a seats. But when we are making an event booking system, it's not necessary that we have seats. What I mean by this. So, whenever like you are going to go in a concert, so there are sections. So what happen? Like if there is a stage in the center, if you are going to watch the concert in the front of that stage, then what will happen? The people are standing in that section. There's a capacity of that complete section. But what happens when you are going to sit on the boundary of that stadium? There you will have the seats. So there are both the concepts are working. There are the sections where people are standing, and there are seats also where people are sitting. Okay, this is the first difference, and there is one more difference that is in the algorithm. When we'll move forward, I will just tell you about that difference as well. Now let's understand the problem requirement of this system as well. It is going to be pretty similar. Many available events that have tickets up for purchase, so it is similar to our use case. All the theaters that have the movie, we can search those movie and we can just see the movie. It's very similar to the second and third point. And locking of the seats that we have also discussed in the last video. Locking of the seats like for some minutes to do the payments, that we have also discussed in our last video. It's pretty same requirement that we have in our last videos. Now, capacity estimates, I forgot to add in my last video, but I'm mentioning it there. So let's consider that there are 100k events are going on in India, and each event have 10 sections. I just explained you sections. Like there is a stage and there is someone standing in front of it. Then there is a section where people are sitting. There can be sections. And let's understand the seats in the section. When in the last video we were studying, so how was the seats related? So first of all, there are theaters. Then after that there are screens, and there are our seats. There was the whole connection. Like first of all, you will go to a theater, then there are screens, and after the screens, you will reach to a particular row, and there are seat number. But here the things are changed now. Here the seats are event ID, means event, and there is a section in the event, and there is a row, and after the row there is a seat number. Okay, and after that there is a status, and a user ID is going to be something else. Like status is free, logged, booked, and user ID, and of course that we studied in the last video, that is our start time and expiry time. They are same. They are very similar to our last video. Now move to the approaches. There are some different approaches here. Let me just tell you about them. So the first and second approaches I explained you in my last video. So I explained you in very depth what is the first and second approach, but now I'm going to tell you just in just a brief what are they. So what will happen in the first, ticket claim after payment confirmed means that user 1 and user 2 will come, and they will both click on the seat. They will both reach on the payments page, and after the payments page, if user 1 is able to complete the payment first, so user 1 will get the seat, and user 2 will get the money back, will get the refund. It is our approach 1. So it gives a bad user experience because the user has to go to the payments page to get the result. Okay, that's why company don't use it. Now the approach 2 I explained you, ticket claim with some locking strategy. So, and there is a start point, there is a star point. The person who comes first will get the lock. So there is user 1 and user 2. They will reach to a seat, and at that time what will happen? In that scenario, like if user 1 come at the T1 time, then user 1 will get the lock, and user 2 have to wait because user 2 came on the T2 time. Like there is some extra time that user 2 have taken. Whosoever is going to come first will get the lock. If user 1 completed the payment, user 1 will get the seat. If is not able to complete the payment into a particular time, then what will happen? Then again the log will be empty. Then user 2 can click it and again book the ticket. So now talk about the third point. This is the point that I was explaining you. There is a difference between the movie ticket system and the event booking system. That is the third and fourth point. That is queue and popular shows. So this is the second difference. So when we are going to see the concepts, we are going to understand the differences. So let's go. So it is just a modification on the second point. So let's study them. So first concept of this video is, please study all the concepts of the video 1. So I will just recommend you to watch the video 1 again, because all the concepts that we have studied in movie ticket system that are going to applied in this video. So we have studied approximately 5-6 concepts. So I will just tell you to go and see all those concepts. The first concept is, please study all the concepts from the video 1, because all the concepts that we are studied in our movie ticket system are going to applied in this event booking system. But this event booking system have some other concepts related to queue and the popular shows. So we are going to discuss about them now. Second concept that we are going to discuss is about queue mechanism. So previous first and second point are done. Now we are going to discuss about the queue mechanism. What is this? So suppose there are two users, user 1 and user 2, came to book a seat in the section. They are not booking a particular seat. They are booking a seat into a section now. Okay, so like this particular section has a count right now, like a total count of this particular section. So what will happen? Like there are multiple users trying to book the seat. Okay, so what will happen? So the count is 100 and we got the request of 1000. The 1000 users are going to book a seat for the particular section. The section is, and the section contains the seat 100. So what will happen? First 100 user will get the lock. That is something that we have studied. And other 900 users, what will happen to them? The first 100 user lock. Fine. What will happen to other 900 users? Are they going to wait? Are they going to just close the screen? So instead of that, there is some different thing that now will happen. We'll provide a wait list number to them that I mentioned it here. So suppose I get a wait list number of 101 or like anything, 800, anything that is according to the queue, according to the book button that I've clicked. So suppose I get some number, and whenever like someone is not able to make the payment, the queue will going to reduce the count. Like now the second chance is going to be mine. This is how the queue size will decrease. Whenever there is a failure in a payment or whenever there is an issue happens, what will happen? A queue size will decrease, and simply whenever I will get my chance, so like suppose I have 100, then it will reduce to 64, 32, 10 and 1. And whenever my turn will come, then I'm going to get my, like I will just get into that locking section, and again now I can just like book a ticket in that particular section. Like my payment page will open, I will get a 10-minute timer. It is the same process if I'm just booking the ticket into a section. Concept 3, how this value is changing on the UI. So previously it is not happening in the movie ticket system. Now let's understand how it is changing in our UI. So now we have to make a dynamic UI. Let's understand it a little bit. So what I mentioned it here. So Taylor Swift concert is going on. Taylor Swift is performing in the center. On the left hand side, we want to book the ticket. So there are 3 users, user 1, user 2 and user 3. So this is completely filled right now. And these user 1, user 2 and user 3 are waiting in their waiting list right now. And the other people are booking their tickets. This is something going on. They are all are waiting it. Now what will happen? The queue number are changing from them. So like the queue number is 900, 800 or something. So what will happen? Our backend server will now, whenever the queue number will change, so our backend server will update the front end UI with the help of the WebSocket. So whenever there is a change in our database, our WebSocket are going to update the front end UI so that their queue number will be reduced, and whenever the queue number will reach to 1 for them, so now they can book the ticket. Now I want you to think a little bit, why this approach will not work for the movie ticket system. Please think a little bit about it and answer me in comment that this approach, I will mention you that this approach will not going to work in a movie ticket system. This is something very event specific. Okay, that's why I'm mentioning this thing, this queue mechanism in the event, not in our movie ticket system. So now let's understand the batch queue. So in the queue mechanism, I just told you that there is a whole list. Like there is a waiting list number of the, like there are 900 people waiting. So let's just take an example. There are 10 seats. There is a section in which there are 10, their capacity is 10, and the first person is going to get the first person will enter first of all, and when it enters into the section, he will get the lock. And all the 9 people are waiting right now. In that scenario, the last person, the 10th person, will get the seat at the 100th minute in the bad case scenario. What will happen? First of all, the first person will book the seat, then the second person, then the third person. And then there are the chances that then the 10th person will get the seat. So for solving this whole issue, what happens? Whenever the waiting queue, we have to reduce the waiting queue. So what happens? So there is a one queue that is maintaining all the numbers, and there is a batch queue. So batch queue, what the batch queue is going to do? It will reduce the number in the sections. So like there are sections are already divided. Like there is a section of 0 to 20. So it means all the numbers that are lie between 1 to 20 will the section will open for them. After that, the section will open to all the number that are lies between 20 to 40, and they will mark them resolved that we have provided them 10 minutes 20 to 40. Now it will open for 40 to 60. This is how the batch queue will work. What will happen inside this queue mechanism? We discussed the queue, we discussed about the batch queue. Now let's understand it for the section with seats. Okay, so previously in till the fourth point, what we were just saying that there are sections, but we are not discussing about the seats. But now what we are going to discuss, about that there is a sections and there are seats also in that section. So what happens that the user reaches, what I told you, the user reaches into the particular section. The 20 people are reaching into that particular section. And when these 20 people are reaching into that section, now what will happen? And the scenario is when there are seats in that section. Previously there were no seats. But what will happen if there are seats in that particular section and multiple people reach there? Because how the multiple people are reaching? Because of this batching queue. These are the seats, seat A, seat B and seat B. C. So what happens? So U1 is trying to book the ticket seat A1. So this is a queue for seat A, this is a queue for seat B, and this is a queue for seat C. So let's understand it and read all the sentences properly. So what will happen? If U1 reaches first, the way I'm making the scenario, if U1 reaches first out of all, okay, if U1 reaches first, so what will happen? U2 will not get the seat, U6 will not get the seat. So U1 will get the seat, A seat, U1 will get B seat, and U1 will get the C seat as well. So U1 will get all the seats, A seat, B seat and the C seats, and all the other people, will not get any seat. If U1 reaches first, and U2 is also standing for the B, he is also in the priority of seat B, but U1 reaches first, so he gets a complete priority for all the other seats as well. So this is something very interesting. Now scenario second, if U2 reaches first, what will happen? If U2 reaches first, so U2 will get the B seat and U2 will also get the C seat. U3 will not get any seat. And here is one more interesting point. Now let's see. Will U1 get any seat in that scenario? No, U1 will not get any seat because U1 wants to book all the seats like A, B and C. But if U1 request is failed, what U1 told that I want seat A, B and C, but B and C are already booked by U2, then A will not get any single seat, but U5 will get that seat in that scenario. This is the approach. This is the something interesting. But the same with the U3 case. If U3 reaches first, then U3 will get the seat C. In that scenario, U2 will not get any seat because U2 want B and C seat. So U6 will get the seat here. And of course, U1 will also not get the seat, and U5 will get the seat for the A1. I also mentioned all the points here in detail. Okay, so please read them and you will be able to understand them pretty easily. So we have completed the point 5. Now let's understand the queue little bit more and more concepts. So what internal data structure this queue is going to use? So let's understand it. So I made some notes here. So what I'm saying, the first order is saying that I want 2 seats. Second order is saying that I want 1 seat. Third order is saying that I want 3 seats. And the fourth order is saying that I want 1 seat. Okay, so I mentioned that we are going to use doubly linked list. Why? So first of all, what will happen in this queue? This order number 1 will go and get the lock whenever the FIFO will come, whenever there is the empty space in that particular section. Now what will happen? The first functionality that we needed is FIFO. Now there is a problem. Like suppose there is a very long queue and there is something like the people in the between, like the third person said to me that I want to leave this queue. In that scenario, when the queue, so we need something so that the third person will leave the queue and our queue didn't get disturbed. So the best way to implement is to use a doubly linked list so that we can just join our node 4 to node 2. And this is the easiest way. That's why we are using the doubly linked list. Otherwise, we can use any single thing. Like we can use an array, we can use a linked list. But in this scenario, when someone can leave from the between, we have to use a doubly linked list. So now let's understand the point middle action on the queue. So suppose there is a section which is having the capacity of 100, but 98 seats are completely filled. In that scenario, what will happen if 98 seats are filled and only 2 seats are left? And there are users like this user, the second user want 3 seats. This third user want 4 seats. So tell me one thing, will they ever going to get any seat? But user 1 can get a seat. User 4 can get a seat. But there is a chance when the user 1 will get a seat, then the seats will become 99 and the user 4 will also not get the seat. So is there a reason to keep them in a queue? So what will happen, their request will reach to the system and they will able to figure it out that now the seats are not there, and then we are going to reject them. So can we make that process little fast? What we can do, if we able to know that our capacity count is less, like we have now 2 seats left and they are requesting for 3 seats in the queue. If we pre-process that queue and we delete all the elements, okay, so like there is no need right now to put 2 seats in the queue. Like we can delete it because I know this request cannot be completed. I can pre-process it. This request cannot be completed. They are still waiting in the queue. So we can delete them. But we have to just keep this 4th element in our queue till the time this first request is going in our system. Okay, we have to keep this so that what will happen, all the requests that are in the queue will get some more priority. They will come forward because we will just remove all the requests, all the wrong requests in our queue by pre-processing them. Now we have to keep this count somewhere. So this is now where we can use our caching. So we can just put all this data in a cache. So what we are going to do, like we can just simply say for that particular section, how many seats are left. So with this we are going to compare and we are just going to process that queue. And we know for all the people who are just requesting more seats than our capacity, we can just neglect them simply. So we need a count. I just mentioned head map. You can just simply put it into a Redis. So now let's move to the final design of an event-based system. So there is a user, the request will reach to our load balancer, then it will reach to our event service. It's the same service that we have discussed in our last video as well, where there is the MySQL and MongoDB. What will happen? A similar use case. All the relational tables are in our MySQL and all the movie details or the event details in our MongoDB. Nothing is going to change in this section. Now in the order service, the things are little bit different. There are some overheads that we have discussed in this video related to queues. So there's a WebSocket that I told you. Whenever the number in the queue is going to change, we have to inform the user with the help of the WebSocket. Now whenever there is an order, and if we can just simply, like if there is a space in our section, what we can do, we can just simply make an order. So we will just simply go to payment service and notification service. What we'll do, we will make a lock on our particular seat and we can do the booking. But what will happen when there is a lot of load, when there is a popular show, we will go for this queue mechanism that we have discussed. First of all, our data will go to the queue, that is the whole queue that we'll just assign with some number, that our waiting list is 1, my waiting list is 2. Now what will happen after the waiting? Whenever the waiting list is reduced, we'll just inform with the help of the WebSocket that we have discussed. Then this queue is going to be processed in the batch. Like this queue will open in the batch because it will be overhead for all the users that have a very huge number. So it will be good if we process the queue in the batch. So we have to make one batch queue, and there is a processor that is able to figure out that we just discussed like for all the users, like if you have to like filter the queue, then how we are going to filter it, that I mentioned you here right now, that we have to store the data in a doubly linked list. And then what will happen if someone wants to leave, the processor will able to leave them. If someone wants to uh, if the capacity is going to fill, so this processor can do some actions on them. After that, whenever they reach to the queue, they can provide a lock to it, and then again it is the same action that is going to be performed on them. So I understand that his whole ticket booking system section is pretty long, but it's good that you have studied it. I hope you enjoy the video. I hope you enjoy the concepts. So if you want to learn more system design, please subscribe my channel, and thank you so much for watching me, and bye bye.